Chapter 5, Lesson 3. Today we're going to take a look at evaluating polynomial functions and identifying shapes of graphs of the polynomial functions. So you can see the chart here. Well, if we just have a constant, you can see an example of the expression here, 12. The degree is 0, leading coefficient is 0, remember. So the degree is the exponent on the variable, and the leading coefficient is the number in front of the variable. So linear, we have the 4x minus 9. So our exponent on the x is a 1, so our degree is 1. Leading coefficient is the number in front of that x, is 4. Quadratic, the x squares, so degree is 2. Leading coefficient is 5. Cubic is x to the third power, so third degree. And exponent, or leading coefficient there is the 8. That's in front of the x to the third. Quartic is x to the fourth, so fourth power, or fourth degree, and leading coefficient is 6. Quintic is 5, so degree is 5, x to the fifth, and the leading coefficient there is the 2. And any other degree, you can see you have any degree greater than 5. So the example here at the bottom, we have a degree of 8, so x to the 8th. And the leading coefficient is the 5 in front of the x to the 8th. So that's kind of all we're doing there for this first part. So in example 1, state the degree and the leading coefficient of each polynomial in one variable. If it's not a polynomial, one variable, explain why. So take a look here at example A. So is this a polynomial? Well, as we did here earlier in one of our earlier sections, this is not a polynomial. Why is it not a polynomial? Because this x in the denominator. So this is not a polynomial. Okay. If it was a polynomial, we can look at it, we could say the degree, again, highest exponent here is the power of 3, so the degree is 3, and the leading coefficient is the number in front of that, which is the 5. In example B, 8x to the fifth minus 4x to the third plus 3x squared minus x minus 3. This is a polynomial. The degree, in this case, the degree is a 5, and the leading coefficient is the number in front of that x to the fifth, which is an 8. So that is talking about degree and leading coefficient of a polynomial. What about evaluating? So you have evaluated already before, so you give us this example here. The volume of air in the lungs during a 5-second respiratory cycle can be modeled by this equation, v to the t. So this tells us that the function, it's a polynomial, has multiple terms there, where v is the volume in liters and t is the time in seconds. Find the volume of air in the lungs 2 seconds into the respiratory cycle. Well, we're looking for 2 seconds. Well, that's our t. Well, what happens when t is equal to 2? We're just going to take and plug 2 in here for t. So we have negative 0.037 times 2 squared, or to the third, plus 0.152 times 2 squared, plus 0.173 times 2. So we just plug that into our calculator, and we can get out then, so v of 2 is equal to 0.658, and we're talking about volume here in liters, so this is in 0.658 liters of air. Alright, The next section here, evaluating still. So here they give us multiple functions. They give us an f function, they give us a g function, and they give us an h function. So the letter in front, f, tells us what function we're using, and 5 is what we're plugging in for x. So f of 5, using the f function here, so x squared, so 5 squared plus 2 times 5 minus 3. So 5 squared, 25. And we're just using order of operations here. 5 times 2, 10, minus 3, so 25 plus 10 is 35, minus 3 gives me 32. So f of 5 is 32. Well, what about h of 4? Well, h of 4, h function, 5x plus 6, so that means 5 times 4 plus 6, 5 times 4 is 20, plus 6 gives me 26. So h of 4 is equal to 26. So we're just taking our value, plugging it in for x, whatever function is given to us. If we have a number, we should get an answer out, number answer. Now, sometimes they give us variables in there. So if they do, here we have another example C, g of 4a. So g function, so g of 4a, we're going to plug in that 4a into our equation then. So 4a squared minus 5 times 4a plus 8. And then we simplify. Now, we're not going to get an actual answer here because we have a variable a in there. So 4 squared is 16, a squared is a squared. Negative 5 times 4a gives me a negative 20a, and then plus 8. Nothing here, and else combines. So g of 4a is equal to 16a squared minus 20a plus 8. And the last one, let's do right down here below, we have h, 2a plus 3. Again, h function, 5x plus 6. So we're taking 5 times the 2a plus 3 plus 6. Then we're going to distribute in this 5. So 5 times 2a is 10a. 5 times 3 is 15. Plus 6. 15 and 6 can combine because they're just constants. So 10a. 15 plus 6 gives me 21. So 10a plus 21. So h of 2a plus 3 is equal to 10a plus 21. So again, we're just plugging in whatever they tell us in for x and solving or simplifying as much as we can. So that's evaluating. Now let's take a look at our graphs. So with our graphs, we have this chart here that kind of helps us out. Any degree of 0, so no x's, okay, horizontal flat line, okay. Degree 1 is just an x in our equation. Degree 2 is an x squared, right? Degree 3, x to the third. Degree 4th, x to the 4th. And degree 5th, x to the 5th. Now, if you noticed, each turn, so here you can see straight line, no turns, okay, horizontal. If it's an x, there's no turns as well. So you can see here in x, straight line, either going up to the right, down to the right, it doesn't matter, but it's a straight line, one direction, linear equation. X squared, you can see I come down, and then I go up. I have two different directions I'm going, okay? So each one kind of there, you can tell me that's my x squared. So looking at the third, x to the third, I'm changing directions 3 times. since I changed direction 3 times, that gives me my x to the third. And you can see here, change directions 4 times, change directions 5 times, x to the fifth. Anytime I change directions, that's going to be an extra exponent on my x. Okay? Now, talk about end behavior. Well, what is end behavior? End behavior determines whether the graph goes up to the right or down to the right, or up to the left and down to the left. Okay? So, what's it doing? Is it increasing? Is it decreasing? Okay, that's my end behavior. Increasing or decreasing. As x approaches positive infinity, as x goes to the right, it's the right side of the graph. As x approaches negative infinity, as x goes to the left side of the graph. Alright? So we'll talk about these a little bit here. We also have degrees. Even degrees and odd degrees. Well, even degrees, 2, 4, 6, 8, any of those numbers there, you can see even degree. So here's even degree 2, even degree 4. You can see they're going in the same direction. They're both going up, or they would both be going down. So your end behavior is the same. Now if you look at your odd degrees here, so 1, 3, and 5, you can see my ends are going opposite directions. So here on the 3, it's going down to the left, up to the right. On the 5th, down to the left, up to the right. Okay, so it's always going to be opposite. That's talking about your even and odd degree. Deals with your end behavior. Okay. Let's take a look at example 4, and we can apply these concepts here with end behavior and our degrees here. So, example 4, so taking a look at our graph, well, what's our degree in example A? So you can see, first degree, change direction, second degree, third degree, fourth degree. So this is an x to the 4th power. Okay? So you can see x to the 4th, it's going in the same direction. So this is even, x to the 4th, even number. As x approaches infinity, as x goes, see here, as x goes to the right. So this graph is going down. So as x approaches infinity, we're going to negative infinity. As x approaches negative infinity to the left, x is going down. So y is going to be, we're going to same direction. So you can see end behavior there, both going down, both going to negative infinity. Now, number of solutions. How many solutions do I have? Well, x to the 4th means 4 solutions. Well, how many real solutions do I have? Again, real solutions intercept this x-axis. So looking at this, I have one solution, real solution here, and one real solution here. So I have 2 real solutions, which then means the other 2 solutions are complex or imaginary numbers. So let's take a look at B. So B, you can see as x increases, as x goes to infinity here to the right, our graph is going down, so we're going to negative infinity. As graph approaches the left side, going to negative infinity, what's our graph doing? Graph is increasing, so we're going to go up to positive infinity. So here you can see graphs going different directions. So that means this is an odd degree. And what would that degree be? Well, this would be 1, 2, 3, 4, 5. So this is x to the 5th. So you can see 5 odd number. How many solutions do I have? Well, I have 5 solutions. How many of them are real? Again, x-intercept, 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 x-intercept. All 5 are real, which then means no imaginary. And take a look at the last one here in example C. Again, we're going opposite directions on our graph. So to the right, as x increases, y is decreasing, so we're going to negative infinity. As x decreases, graph is increasing, so we're going to positive infinity, which means it's going to be an odd degree. Well, what is that degree? Well, a degree is 1, 2, 3 changes, so x to the third in this problem. Now, how many real solutions do I have? Here's a real solution, here's a real solution, and there's a real solution, so 3 real solutions, no imaginary solutions. So hopefully that makes a little bit of sense there with the end behavior, number of solutions as we're increasing and decreasing with our degrees. So a little bit of information there on polynomial functions, evaluating, looking at their graphs, and the information from their graphs to determine what kind of polynomial we're dealing with.